The pen, sir?
पेन नहीं है?
No.
एक बार उसको पूछना। यहाँ पे है, यहाँ पे। पूर्विता।
सर पेन, उस बोर्ड का पेन। नहीं। हाँ याद आता।
Close it.
से एक काम करते रुके।
कोई बात नहीं।
ठीक है, वो अब नहीं गिरेगा।
कितने लोग जाएंगे? So hello everyone, just confirm me once if I'm audible to all of you. अगर voice audible है तो please confirm करना. Sir, is APAR ID compulsory? No, APAR ID is not compulsory right now. Like you can skip this part and just apply for this exam. But later part, as I already conveyed, कि आगे जाके जब fellowship के लिए या ICAR counseling के लिए apply करोगे तब mandatory हो सकता है. तो now you can buy some time and generate it. अगर उसमें भी कुछ problems है, defects है, उसको rectify कर सकते हो. For now, for applying for this exam, you can skip that part and click on no and then complete your application. उसको कर सकते हो, कोई दिक्कत नहीं है, ठीक है? Sir, good evening. Audible, sir. Okay. Thank you so much. So, how are you all? So, I'm very excited to start this Soil Science Marathon series. आपके favorite mentor के साथ like we'll be starting this series. Like you people requested it previously. Like बहुत सारे students request कर रहे थे कि sir marathon. And also like from the previous batch, if you know like in the previous batch also like we conducted the marathon series, but there was one particular request that sir marathon series should be conducted at least like 2 weeks before the exam. So that's why like we are kick-starting our marathon series almost a month before the exam, so that each and every student who is writing this exam of ICAR PG, so they should be benefited. And this marathon series, as I told you, like the marathon series that we are going to conduct, it's not just like a single class in which like we will be entirely covering the subjects. No, we won't be doing that. We will be covering the marathon series like section wise. For each and every section there will be like one marathon series. That means like whatever we are going to cover in this marathon series, that will be definitely helpful in your exam. I mean to say like if you are giving 4 hours of your time, 2 hours of your time, 3 hours of your time to attend this marathon series, then that means we should be able to give you back for whatever time that we are taking from you. So trust me, like if you complete all the marathon series that we have scheduled and planned, at least 60 to 70% of the syllabus will be covered just by these classes. Just by attending these marathon classes plus accessing the PDFs of this marathon, 60 to 70% of the syllabus will be covered and you will be able to revise it. That's the power of marathon that we have scheduled and formed for you people, that we have planned. And thanks to our all mentors like who are very much dedicated and they agreed to conduct this marathon series, because you know conducting 2.5 hour 3 hour sessions are too much exhaustive, and in the very last moment compiling everything in a single PPT, single PDFs and presenting with you all, so it's another challenging task. But still our mentors were very positive that they came, they took this challenge and they are here to start the marathon. And for your subject of soil science, I'm very excited that we are starting it at the right time, what we have planned for you people. So enjoy this marathon. So but एक problem भी है, like I know like many of you are like following the YouTube classes, but like you people are not like supporting our mentors or not even commenting, appreciating them for their videos. Like we conducted like most expected series, we conducted the PYQ series, so both of them are already done. I know like most of you have watched it and benefited from that, but I see hardly few comments on the YouTube. So if you really like the content, if you really think that the mentors are giving their best, I want you to appreciate them, not me, not the platform, but the mentors like who are giving their best. So I want you to recognize their efforts and appreciate them on a public platform so that they will be motivated. This is all about motivation. That's it. See, what keeps us motivated is you people, like your appreciation, your feedback, your views are the one which will keep us motivated to give more and more and more. So that's why I request you, like if you like the content, देखो कुछ भी हो, like अगर अच्छा लग रहा है, अच्छा नहीं भी लग रहा है, सब कुछ बोलना, सब कुछ कमेंट सेक्शन में बताना। अगर कोई भी करेक्शंस हो, कोई भी अच्छा लाइक फीडबैक हो एंड इंप्रूवमेंट चाहिए होगा तो डेफिनेटली विल बी डूइंग इट। एंड इफ आई वुड बी नॉट बी आस्किंग दिस इफ वी आर नॉट प्रोवाइडिंग द क्वालिटी कंटेंट। क्वालिटी कंटेंट का अगर बात करूंगा, लाइक you know the quality, like I should not be speaking about the quality, you know it already, but still every little efforts need the recognition and appreciation. So that's why I request you people, see, if you want us to continue this series, if you know, like we are starting from soil pedology and we'll be continuing till the minor subject also. soil science में जितने भी topics आएंगे, like we'll be covering each and everything, ठीक है? जैसा मैंने बताया, like if I said like 60 to 70% of the syllabus will be covered, I mean it, okay? You will be able to cover it with us. And हाँ, PDFs, सर बहुत सारे स्टूडेंट्स पूछ रहे थे कि PDFs कहाँ से मिलेगा? So where you will be getting the PDF? So PDFs will be uploaded in the test series course. So that will be accessible for the master course students and also for the test series students. If you have purchased the test series or the master course, for both of you, these PDFs will be directly available. उसको directly course के अंदर हम upload करने वाले हैं। हर एक क्लास के बाद 1 घंटे के बाद तुरंत वो अपलोड हो जाएगा। तो आपको क्या करना है, एक चीज मैराथन देखना है, दूसरा चीज पीडीएफ से आपको रिवीजन करना है, तभी आपका 60 to 70% मिनिमम सिलेबस कवर होगा। ऐसा नहीं कि आप मैराथन देख के छोड़ दिए तो आपको कवर हो जाएगा। एंड हाँ, ये भी बता दूं, आई ऑल्सो टेल यू दैट दिस मैराथन्स आर क्विक एंड क्रिस्प। सो लिखने में टाइम वेस्ट मत करना। टाइम वेस्ट नहीं बोलूंगा, टाइम स्पेंड मत करना इस लास्ट मोमेंट में। सी, डोंट पॉज द वीडियो एंड कीप ऑन राइटिंग वॉट एवर इज ऑन द बोर्ड। दिस इज नॉट द राइट स्ट्रेटजी फॉर द लास्ट मोमेंट। जो भी चीज़ है रनिंग नोट्स लिख सकते हो, आई वुड कॉल इट एज रनिंग नोट्स, लाइक वॉट एवर यू कैन रीड write along with the mentors, keep writing it, whether it is like how bad it is, no problem, just write it as fast as you can. Later just access the PDFs and from there do the revisions. Do not keep writing everything. This is not the right time to write, this is the right time to revise. तो ज़्यादा टाइम आपको रिविजन करने में, रिकॉल करने में, डिस्कशंस करके सब चीज़ों को याद करने में और कॉन्सेप्ट्स को समझने में इन्वेस्ट करना चाहिए, ना कि तुम आप लोग फिर से वही नोट्स लिख रहे हो। आपने ऑलरेडी लगातार 1 साल से 6 मंथ से 3 महीने से नोट्स लिख ही रहे होंगे, लेकिन इट्स नॉट अ टाइम टू कंटिन्यू दैट, ठीक है? आई एम अनेबल टू फिल द फॉर्म, आई ट्राइड अ लॉट एंड ऑल्सो मैसेजिंग यू पर्सनली बट डिडंट गेट द PDF फॉर 2 months strategy, but I want those marathon. How? Yeah, that's what I told you, like for all the students who want this marathon, so marathons are exclusively available for the master course students and also the test series students. देखो, आप मास्टर कोर्स लिए हो या नहीं लिए हो, सेल्फ स्टडी कर रहे हो, दैट्स एंटायरली अप टू यू, ठीक है? क्योंकि उसमें ऐसा नहीं कंपल्सन कि सबको मास्टर कोर्स लेना ही पड़ेगा तभी रैंक ऑन आएगा, ऐसा कुछ नहीं है। आपको अगर कंटेंट डिसिप्लिन वाइज चाहिए तो देन यू माइट हैव गॉन फॉर मास्टर कोर्स। बट एक चीज है, देयर इज वन कॉमन थिंग, if you are preparing seriously for this exam, attending the mock test questions, attending the test series is very much important. You ask any of them, any of your seniors who have cracked these exams, one common thing they will definitely suggest to try the maximum number of questions and maximum number of quality questions, not the questions that you get anywhere. You want to try the quality questions as per the standard of ICAR. तो इसलिए मैं डेफिनेटली रेकमेंड करूंगा कि आपने अभी तक मॉक टेस्ट सीरीज नहीं लिए हो तो it was for 499, but उसको और भी कम करके now it is only available for 399. So in this you will not only get the mock test questions, you will get the text explanations, video explanations, marathon PDFs and हाँ, हम स्टूडेंट्स को मास्टर कोर्स के ग्रुप में भी ऐड कर रहे हैं, जो भी मतलब टेस्ट सीरीज ले रहे हैं, द स्टूडेंट्स हु आर टेकिंग द टेस्ट सीरीज, वी आर ऑल्सो एडिंग देम टू द मास्टर ग्रुप ऑफ व्हाट्सएप। तो वहाँ से क्या होगा, लाइक कभी भी कुछ भी डाउट आए, कोई भी क्वेश्चन अटेंड करने के टाइम पे या कोई भी कॉन्सेप्ट पढ़ने के टाइम पे, उसको डायरेक्टली यू कैन पोस्ट इट ऑन द व्हाट्सएप ग्रुप एंड गेट द आंसर्स इन नो टाइम विद आवर मेंटर्स। ओके, please join the PDF, please pin the PDF. Yes, we'll do it, okay, don't worry. Like once it is uploaded, we'll pin it and we'll also inform you in the master group and also in all the free groups like that the PDF is uploaded, you can access it directly. And before she comes and start this class, so I would again remind you people, see, if you are liking this marathons, if you want us to continue and give 100%, like we are already giving 110%, but still if you want to continue this, motivate us by appreciating and also putting your reviews on the YouTube, okay? And also convey this to all your friends and juniors, like who will be preparing for these exams or who are simultaneously preparing for these exams. Your views, your comments are the one which will motivate us to give more and more and more. Okay, start kare. So if we can start, just give a thumbs up. अगर हम start कर सकते हो, drop a thumbs up. Sir, are these PFQ repeated? Yes, PYQs भी रिपीट होते हैं, एटलीस्ट कंसिस्टेंटली कुछ परसेंटेज तो हमेशा एज इट इज रिपीट होता है, सो यू कैन नॉट मिस द PYQs, यू हैव टू डू इट. यस, सो आई वांट थम्स अप फ्रॉम एवरीवन इफ वी कैन स्टार्ट राइट नाउ. अगर स्टार्ट कर सकते हैं तो सबसे थम्स अप, कितने जितने लोग भी ज्वाइन किए हो, जस्ट ड्रॉप अ थम्स अप. यस, ओके. Yes, sir.
So, hello guys, welcome back to our first marathon session where we will be starting from the very first topic, which is soil pedology. Okay, and I am your mentor today, and my name is Purbita. And those of you who know me, and that I am pursuing my masters in ICAR IRI New Delhi under the Division of Soil Science and Agricultural Chemistry. Good evening to each and every one of you. So I want your full attention and concentration in this marathon session because this is going to be everything that you had read so far. Okay? So let's begin. So first we will start with the very concept or the very root of what is soil and what is land. So how is soil different from that of land? So first of all, when you think about soil, you will think that it is a three-dimensional natural body. And whenever you think about land, land is something that is covering the entire surface of the earth. So it is two-dimensional. So this is one of the, yes, good evening to each and every one of you. Yeah, we will also bring soil physics marathon. So tomorrow there will be soil physics marathon and we will continue it for 2 consecutive days. So don't worry, just attend the marathon. Okay, whatever I am teaching right now, be focused, be concentrated, and you will get everything, okay, that you need. So land, it is actually two-dimensional and soil is three-dimensional. This part is very important. Yes, there will also be marathon for analytical chemistry as sir rightly mentioned. Every minor topic will be covered, okay? Including the minors, including the ones that are often neglected, everything will be covered, okay? But please focus on what I am teaching right now. So land, I said, it is two-dimensional and soil is a three-dimensional entity. So this is the basic difference between soil and land. And land is the physical environment consisting of all the different factors, and within that, one factor that you have to read is soil. So if somebody asks you that what is the difference between land and soil, then land is one of the factors that constitutes soil. But soil is something else. Soil is a three-dimensional natural body. Okay. So you see that there are different scientists. So this concept of soil, when it came first, different scientists proposed different hypotheses. So the first one, and we will always have to remember who gave the definition. Okay, who gave, which scientist gave that particular definition, you have to remember, because match the following kind of questions might come, MCQ type of questions might come, so then you have to do it correctly. So first you see that Ruffin said that it is a mixture of Earth's uppermost mantle of weathered rock and organic material. So initially the concept of soil was not that defined. So Ruffin was the first scientist who said that what can it be? The uppermost mantle. So when we go into the layers of the earth, you will find that what is mantle, what is core, what is crust. You will be okay with that. But just remember that according to him, it is just a mixture of the earth's uppermost mantle of what? Weathered rock and organic matter. Okay. Now for Hilgard. Hilgard said that soil is more or less a loose and friable material. So you have to remember the key terms that are associated with each and every scientist. For Ruffin, it is uppermost mantle. For Hilgard, it is loose and friable material. And for Dokuchev, so every one of you know this name Dokuchev, and he is called as the father of soil pedology or the father of modern pedology. So whenever there are two terms, father of pedology or modern pedology, anything will be associated with Dokuchev, that you should not forget. And he was the first scientist, he was a Russian scientist. According to him, he actually classified the soil and he brought about this concept of soil science into existence. So according to him, the soil is a natural body, okay, natural body. Then, so you have to remember the key terms along with the scientists associated. There are other two things. First, there is scientist Whitney, and he gave the concept of soil to be a nutrient bin. Okay, he gave the concept of soil to be a nutrient bin. Then there was Jenny, and Jenny said that soil is a naturally occurring body. Why am I emphasizing these scientists and these terms? Because they come in the exam. Okay. Now, according to Whitney, it is a nutrient bin, and according to Jenny, it is a naturally occurring body. So, when with Dokuchev, it is natural, with Jenny, it is naturally, because Jenny has Y, so naturally should also have Y. Okay, so in this way, you can remember. Now, coming to the basics, that what is pedology. So pedology comes from two terms, okay. It is a Greek word. So wherever you will find logy, you will say that it came from logos, and logos means to study. And pedo, so it came from this term, that is pedon, means soil. Okay. So can anybody comment that what is the full form of soil and from which language is the word soil derived? Comment in the chat box. Okay. So pedology actually deals with the study of genesis, survey, classification and geological distribution of the soil. So it is the overall study. But whenever it is pedogenesis, so whenever I convert this logy into genesis term, that means it will only deal with the origin of the soil. So you should not get confused. Logy means overall study, genesis means the origin. So I am still not saying, yes, Latin word solum, and what is the full form of soil? What is the full form of soil? Soil means, yes, soul of infinite life. Very good, and it came from the Latin word solum. Fine. Now, so you see that pedology is a Greek word, whereas soil is a Latin word. Okay, should not forget that. Then coming to the next one, that is petrography. So wherever there is graphy, graphy will suggest the description, and petro means rocks. Okay, so wherever you will find petro, just associate it with rocks. Petrogenesis, formation of rocks. Petrography, description of rocks. Okay. Then another thing, which is edaphology, this is very, very important. J.S. Kanwar said soul of infinite life in 1992. Okay, very good. So, soil means soul of infinite life by J.S. Kanwar in 1992. You guys are smart. Okay. Okay. So, I am writing it down here. Now, coming to another term, that is edaphology. Okay, Bachman and Brady said, yes, Bachman and Brady said, that's Bachman and Brady. It's not Bachman, it's Bachman and Brady. Very good. So, Bachman and Brady also said that soil is what? A dynamic natural body. That is, it is not static, it is dynamic. We'll come to that. We'll come to that. Okay. Okay. So, coming to this thing called edaphology, this is specifically when soil is related with plant nutrition. Why do we study soil? We are agriculturists, so we are concerned with the growth and development of the plants. So, that's where edaphology comes in. So, this edaphology came from two words. Edaphos means soil and logos means discourse or to study. Then geology, so this is simply the study of Earth's crust, and geodesy, you see, you will not find this anywhere. So, geodesy means the shape and size of the earth. So, whenever you study the shape and size of the earth. Okay, clear this? Clear? Coming to the next part. So, now before starting the soil, you have to be very clear with some things. What is the difference between soil and the earth's crust? Okay. So, whenever I say the earth's crust, then I will take the entire part of the upper earth, okay, or the outer earth. But whenever I am talking about soil, you should remember that soil is the uppermost part of earth's crust. Okay, uppermost part of the crust. Crust is the uppermost part of the earth, but soil is the uppermost part of the crust. That is influenced by different weathering agents. So, this you should not forget. And another important thing is that in the soil we have organic matter or the organic carbon. So, when you go deep inside the earth, you will find no organic matter or no organic carbon over there. You will find several minerals that have heavier densities, right? And for the soil, because it is present at the outermost part, it is the only layer that has a high concentration of organic carbon. But whatever minerals are present in the soil, they are correlated with that of the crust. Okay, so you should not forget that it is the uppermost part of the crust. Now, coming to the different parts of the earth, you can see from here that the first part is crust. Then we have mantle and then we have core, and each and every part is divided into outer, inner, outer, inner, outer, inner. Okay. So, first let us read. So, this is the chemical composition of the earth, and I'll tell you percentage by weight of the elements. Okay. So, the core is the innermost part of the earth, you have to learn, and the thickness is about 3500 kilometers. So, can anybody comment what is the density of overall earth? Density of earth as a whole. And it will be great if you can also comment that what is the individual density of crust, mantle and core. Core one is written already, 9 to 12 gram per cc. But if you can comment, yes, it is 5.5. So the density of the earth as a whole is 5.5 gram per centimeter cube. But what is the density of the crust, mantle and the core? Yes, the answers are coming. So in the crust, it is 2.6 gram per cc. For the mantle, it is around 3 to 4.5 gram per cc. But when we combine all of this together, then the entire, yes, okay, now core is not 3 to 4, core is 9 to 12 gram per cc, okay. So now, okay, so here it is already given, and crust, you should remember that we have two kinds of crust. One is continental crust and the other is oceanic crust, okay. So oceanic crust is actually thinner. Okay, oceanic crust is thinner, only 5 to 15 kilometers or around 5 kilometers, and the continental crust is a way thicker, 35 kilometers around. But the density of oceanic crust, is more than that of continental crust. So this has higher density. So this has higher density than that of continental crust. Okay. Another thing you should not forget that we can call the continental crust to be Cl and the oceanic crust to be CMA. Why? The Cl means silicon and aluminium, they are dominant, and in the oceanic crust silicon and magnesium are dominant. And do not ever forget that in the core the most dominant metal is iron. In the core the most dominant metal is iron. Okay. Now coming to, so here it is all written whatever you had just told me. Now coming to another thing, that is the different discontinuities. The different discontinuities in the earth. So if suppose this is the entire earth, okay, this is the outer core, sorry, outer crust, okay, then this is the inner crust, I am assuming inner crust. Then we can have the outer mantle, inner mantle. This is the outer core and this is the inner core, suppose. Okay. Then what will be the different lines of discontinuities? This is a good question. What can be the different lines of discontinuity? So within the outer crust and the inner crust, there will be conrod discontinuity. Conrod. Within the inner crust and outer mantle, it is Mohorovičić or Moho discontinuity. Then we have Repeti. Then we have Gutenberg, and then finally we have Lehman. Okay, so the discontinuities also you have to remember the names. What are the discontinuities and where they are present? Okay, what are the discontinuities and where they are present? This can be an important question. Okay, now coming to the different spheres of the earth. So all of you had read in geography. This part is very easy. The solid sphere is called lithosphere. The liquid sphere is called hydrosphere, and the gaseous sphere is called atmosphere. Now, please comment what are the percentage contribution of each and every sphere. What are the percentage contributions of each and every sphere? Okay, and the interaction of all these spheres will form the biosphere that leads to the formation of soil. But some scientists, they also say that we have a pedosphere, and that pedosphere is lying at a junction of all the four different spheres, that is atmosphere, hydrosphere, biosphere and lithosphere. And at the four different junctions, whatever is coming, we can say that it will form the pedosphere, because it will take into account life as well as air, then water as well as the solid part. Okay, lithosphere is 91%. Lithosphere they are saying 91. So what about hydrosphere and atmosphere? Okay, atmosphere is 0.03%. If I am not wrong, then the hydrosphere is about 6.91%, I guess. 6.91%, yes, fine, and the lithosphere is 93, right? I was asking the exact value. So these are the percentage contributions of the different spheres. Okay, so this part is also a bit easier. Now we come to the average composition of the earth's crust. So never ever confuse this term with soil. Even though soil is the uppermost part of the earth's crust, this is the composition of the earth's crust that we study. Okay, So this OC alpha Ka Na Ka Mg. So this series is very, very important. You have to remember that. The abundance of these minerals and their percentage contribution towards the earth's crust. Okay. So it is all written over here. Mostly that you have to remember is that you see from the figure that the oxygen and silicon, they will contribute to about greater than 70% of the entire earth's crust. So this question comes in the exam, that name the two elements that contribute. And you also should not forget or confuse between all these terms: elements, metals, non-metals, basic cations. Okay, yes, so they are also writing, so some smart people are also writing the ranks of the elements. Okay, very good, very good. Okay, now see, first is, if I talk about the most dominant element, then it will be definitely oxygen. It is not a metal. But if I talk about the second most dominant element, see here it is written element, then it is silicon. But if I talk about the most dominant metallic element, then it will be aluminium. And the most dominant exchangeable basic cation is calcium. You should not forget that. Even though we have aluminiums in our soil, Al3 plus ion is there. Even though we have iron, Fe2 plus or 3 plus, but we are asking about the most dominant basic cation that contributes to the soil, and that will be calcium. That will not be aluminium, that will not be iron, because aluminium, it contributes to acidity in the soil. So it is on, and only in acid soils the aluminium will contribute much higher percentage. And also the iron, that is also similar, it's dynamic, so it will also contribute towards acidity. But aluminium is the most dominant exchangeable basic cation. Okay, most exchangeable basic cation. Okay, now see, the non-metal percentage is 75 or 3/4, that constitutes oxygen and Si4 plus, and the metal percentage is only this 25%. Okay, so these are the elements in total, and it is the crust. Now, so here we had already mentioned what are the percentages contributions of atmosphere, hydrosphere and lithosphere. Now, which sphere covers maximum portion of the earth by volume? So, whenever it is volume, it is hydrosphere, because see, it is by volume. And all these are the contributions by the weight. So, that also you should not confuse. So, hydrosphere will cover the maximum portion by volume, and which sphere will cover the maximum portion by weight? It is lithosphere, because we know that 70% of our earth is covered with what? Okay, okay, fine. Yes, okay. Now coming to rocks. So these are the dominance of single elements. When we talk about minerals, when we will come to minerals, then we will see that the dominance of minerals, it also varies. Okay. First, what are rocks? So you all know these are naturally occurring hard mass of mineral matter. Just naturally occurring masses. And if we want to extract the minerals, it is composed of more than one minerals. And if we want to extract the minerals, from a rock, we will use its ore. So what is the difference between an ore and a rock? Ore is something that has a maximum contribution by one mineral only that we want to extract. For example, if we want to extract phosphorus, then we can always take the apatite mineral. So we can say that this apatite is an ore of phosphorus. Okay, like this. So ores and rocks, they are also not synonymous. Ore is when the percentage of one mineral will be much higher. Okay, pumice made by volatile gas. Okay, we will come to that. Ore with impurities and mineral is pure. Yes, and minerals are extracted from ores. But I am telling you the difference between ores and rocks. Okay, so rocks are also composed of more than one minerals, and we have this. What is it? The stratification of different rocks. So first, igneous rocks. Never forget that they will be present at a very high temperature and high pressure. So if someone asks you that what is the first rock that has been formed after the solidification or after the cooling down of the earth, it is nothing but igneous rock. Okay, and this igneous rock again can be, let's see if it is there or not. Okay, so let's just break it down. The igneous rocks can be classified into two groups, right? Igneous rocks can be classified into two groups. One is extrusive and the other one is intrusive. Write in the chat box what are the alternative names of extrusive and intrusive rocks. What are the alternative names of extrusive and intrusive rocks? So, whenever it is extrusive, that means it is present in the exterior, right? So, whenever the magma, it will come out. So, whenever magma comes out of the earth, it is called as lava. So, whenever that lava cools down, then it forms the extrusive rock. So, it is formed on the surface of the earth. Yes. So, there are smart people. So, this is called as volcanic and this is called plutonic. Right? So, whenever the magma comes out and it crystallizes on the surface of the earth, because it is getting enough oxygen and enough temperature or enough time to cool down, these extrusive rocks are generally fine grained. But for intrusive rocks, they are actually formed by the cooling down of magma within the surface of the earth, and that is why they are coarse. That is why they are coarse grained. Okay. And now coming to the examples of intrusive rock. What are the examples of intrusive rock? Two most abundant things are there. One is granite and the other is gabbro. And within the extrusive rocks, one will be basalt and the other one will be rhyolite. Okay, basalt and rhyolite. Extrusive basalt, andesite, trachyte, pumice. Okay, but for this andesite and trachyte actually, yes, it is fine extrusive. Rhyolite, andesite, trachyte, basalt. Okay, you all are smart. But again, when we will do the classification of rocks based on the silica percentage, then you will find that all this trachyte and andesite, they belong to some different categories. Okay. So, first let us talk about granite and gabbro. So, this granite is the most dominant intrusive rock and basalt is the most dominant extrusive rock. So, both of these, they are dominant with this feldspar kind of minerals, and gabbro, it is similar to basalt, but it is coarse grained. And for rhyolite, it is similar to granite, but it is fine grained. So, who can tell me what kind of a rock pumice is? What kind of a rock pumice is, whether it is extrusive or intrusive? This is a question for you guys. What kind of a rock pumice is? Okay. Next, coming to sedimentary rocks. Yes, we will come to that. Mafic and felsic. Yes, very good. So, pumice is an example of extrusive rock. Pumice is an example of extrusive rock. Now, whenever we are discussing the rocks, let us also discuss the different percentages. So, according to the silica percentages, we can say that we have several acidic kind of rocks and then we have some basic kind of rocks. Okay. So, acidic kind of rocks will have a silica percentage of more than what? Comment guys. Acidic rocks will have a silica percentage of more than? Oh, fine. Okay. Acid rocks will have a silica percentage of more than 65%. Very good. More than 65%. And there are some rocks that are present in between this acidic and basic, and they are called either subacidic or subbasic rocks. Okay. In case of subacidic, the acid percentage is a bit higher. So, we can say that acidic means 65 to 55 or 60% like that. So, within the acidic rocks, what will come? Within the acidic rocks, what will come? So, within the acidic rocks, your granite will come, right? Granite will come. Within the acidic rocks, and tell me that rhyolite, yes, rhyolite is also there. So, along with granite, there will also be rhyolite. And within the basic rocks, along with basalt, will come your gabbro. That's why I mentioned that these have similar properties, but only they are extrusive or intrusive. That is the difference. For those of you who were saying that cyanite, andesite, trachyte and diorite, all these rocks will fall under the subacidic or subbasic category. Okay, cyanide, andesite, trachyte, rhyolite, all will fall, trachyte, diorite, sorry, all will fall under the subacidic or subbasic category. Okay, basic is basalt, gabbro, okay, neutral, andesite, yes. That is why neutral means what? Subacidic or subbasic category. Cyanide and diorite will be there, and trachyte and andesite will be there. Okay. Next, coming to sedimentary rocks. So, from the name only, it suggests that it has been derived from sediments. Now, what can be the different kinds of sediments that are used for sedimentary rock? One can be clastic and the other is non-clastic. So, whenever we talk about clastic sediments, these sediments are actually derived from the physical weathering processes or physical processes, that is, they may be of detrital inheritance. Detrital inheritance or fragmentation, that is, no chemical process is involved. I guess we can call neutral. Yes, we can also call that neutral, no worry. Now, in case of non-clastic sediments, they are actually formed by the process of chemical reactions. For example, limestone, okay, or halite. They are formed after evaporation. Okay. Diagenesis process response. Okay, you guys are moving so much ahead. We will come to that. No worry. So, non-clastic sediments are those that are formed due to chemical reactions. Okay. So, limestone, that kind of a rock will fall under the non-clastic one. And within the clastic ones, this conglomerate will come. Okay. Conglomerate will come, sandstone will come, but dolomite, it is not coming over there. Okay. So, these are actually a few examples of sedimentary rocks, and you have to remember that these are stratified, highly stratified. Okay. Now, another thing I wanted to clarify is whenever we talk about the rocks, we have actually two basic kinds of minerals or rocks. First is primary mineral and the other is secondary mineral. Primary and secondary. We will come to that later on. But just for the sake of understanding, remember that primary minerals are the ones that have greater than 2 millimeter in they are greater than 2 millimeter in diameter, that is, they are greater than the clay sediment or the clay fraction. So, they have larger sizes, and these primary minerals are actually responsible for the formation of igneous rocks. But whenever we come to the secondary minerals, these are in the clay size fractions. So, they will help in the formation of secondary rocks. Dolomite, limestone, precipitated type, yes. Okay. Coming to the third category, that is metamorphic rocks. So, these are derived by a process called metamorphosis from the initial igneous and sedimentary rocks. And this is very important, that is up to 5 kilometer. If I talk about only the 5 kilometer of the upper of the entire Earth's crust, that is, the igneous rocks will be less and the sedimentary rocks will be more. But whenever I talk about the Earth's crust as a whole, then the igneous rocks will dominate 95% and the sedimentary rocks will dominate only 5%. So, you are smart guys. So, can you tell me what is the percentage? So, if I talk about suppose the upper 5 kilometer. So, tell me what is the percentage of granite, percentage of basalt, okay, then percentage of shale, percentage of sandstone and limestone or dolomite. Quickly in the chat box, I want the answer. Okay. No, shale is not 74. See, I said that the entire sedimentary rocks, just a second guys. नहीं ये तो on है.
Students, like very sorry, power is there was a power cut, unexpected power cut. So we'll wait for another 2 minutes. If the power comes again, we can continue, or We can start once the power is on. Otherwise, like we have to wait. ठीक है. Sorry for the inconvenience. This was very unexpected. ऐसा होना नहीं चाहिए था. Okay. No worries. We are power charged for the season. Thank you so much. Let's wait for another 5 minutes. 5 minutes तक लाइव ऐसा ही चलता रहेगा. अगर 5 minutes के बाद भी, let's say what's the time now? It's 6:49 ना. Let's wait for 7 o'clock. 7 o'clock तक वेट करेंगे. अगर पावर आ रहा है तो कंटिन्यू करेंगे, वरना उसको नेक्स्ट सेशन में पार्ट 2 में करवा करेंगे. ठीक है. जस्ट बी पेशेंट फॉर सम टाइम. एटलीस्ट सिस्टम में यूपीएस है तो 10-15 मिनट 20 मिनट इसमें चल जाएगा, लेकिन स्मार्ट मोड में कोई यूपीएस नहीं हो सकता, तो वी हैव टू वेट फॉर द पावर. इज इट फाइन? इफ इट इज फाइन प्लीज गिव थम्स अप. बहुत नाराज हो क्या? इफ इट इज ओके, लाइक इफ यू आर एबल टू वेट टिल 7, 10 मिनट के लिए वेट कर सकते हो ना? इफ यस, जस्ट गिव मी थम्स अप. ओके. Okay guys, thank you so much. स्टूडेंट्स 7 बजे के लिए अभी 2 मिनट बचा हुआ था, आ गया लाइट। सारे लोग हो, like are you all there? चले गए? Are you all there? हो यहाँ पे या चले गए? Yes, yes, okay, good. देखो, I don't know like whether you are lucky or we are lucky. I think both are lucky.
Yeah.
जो डेडलाइन दिया था उससे 2 मिनट पहले स्टार्ट हो गया। Yes, okay, good. Alive and kicking, good, good. अगले साल के लिए एनरोलमेंट्स बढ़ाओ, एक इन्वर्टर भी लेके आ जाएंगे। नेक्स्ट टाइम से तुम्हारा जूनियर्स को एटलीस्ट प्रॉब्लम ना हो, लेकिन उसके लिए तो बहुत मेहनत करना पड़ेगा, हमें भी और आपको भी। पुर्विता मैम का सेकंड क्लास ऐसा हो रहा है, पावर कट से बंद हो रहा है। शी वाज वेरी अपसेट।
मैं हुई अनलकी।
नहीं नहीं, इतना भी नहीं। स्लाइड नंबर याद है?
नहीं नहीं नहीं, पहले पहले। इससे पहले होगा।
ये यार देखो, टॉन्ट कर रहे तुम्हें, यू आर यार टू एंड यू से यू आर अनलकी।
If I were lucky, then I would have been year one, no?
शाबाश। ये मत सुनना, थोड़ा डिप्रेशन में चले जाओगे। शी इज सेइंग लाइक if she was lucky like she will be getting AR1। मैं इसके लिए कुछ कमेंट नहीं करूंगा। यही था।
हाँ।
कहाँ गया तुम्हारा स्लाइड्स? थिंक इट इज लोडिंग और समथिंग।
हाँ,
जस्ट
I also think that. No.
हम करते इसको सेव कर देते।
Okay, guys, wait for some more time.
इतना वेट कर ही लिए हो तो और 2 मिनट वेट कर लेना। अरे बंद ही हो गए ये।
Sir. Just 1 month wait and we'll be in ISI, okay?
We'll be waiting to welcome you all.
Yeah. सिक्सटीन के बाद से तो नहीं होगा, to 14 instead.
इसको सेव।
Okay.
Just give us one. Just give us 2 more minutes, okay? Let's start.
Hmm.
But Usana, you're audible.
Hello guys, am I audible? Okay, so we'll start. Sorry for the interruption. So what we were discussing, I actually forgot. Um, so yeah, we were discussing the different percentages of rocks, okay, on the surface of the earth, and we had seen that, suppose I told you that in the upper 5 km of the earth's crust, 74% of the rocks will be sedimentary, right? So within that 74%, 52% is contributed by shale, and then the 15% by sandstone, the rest 7.5% by limestone or dolomite, or 7 or 7.5 whatever, and 8% by others. Okay. And within the igneous rocks, whenever it is 18%, within that 18%, 15% by granite, and the rest 3% by basalt. Clear? But whenever we talk about the entire Earth's crust, then we have 95% dominance of igneous rocks. And for the rest 5%, we will have 5% sedimentary rocks. For the rest 5% sedimentary rocks. Sorry, just wait a second. Yeah, okay. So for the rest 5% sedimentary rocks, we will have 4% as shale, okay, and rest 0.75% as limestone or dolomite. So you must not forget the different percentage abundances of, yes, sandstone. Okay, sorry, sandstone is 0.75. So this is not limestone, this is sandstone. Okay, thank you. So this is sandstone, and limestone and dolomite is 0.25%. Very good. Okay, so this you should always remember. Now coming to the metamorphic rocks, I said that they are formed due to a process of metamorphosis. So this is also important. Here we have a chart that which of the following rocks are formed at which from what pre-existing rock. And one thing I wanted to add is the order of metamorphism. So this metamorphism can be either your thermal metamorphism is due to temperature, or dynamothermal, that is the combined effect of temperature and pressure together, thermal or dynamothermal. And there are different sequences of metamorphism. For example, the first one will be gneiss. The first one will be slate. Okay, sorry, not gneiss. The first one will be slate, and from slate, then we will have phyllite. From slate to phyllite, then schist, and then gneiss at last. So this will be the order of metamorphism. First slate, then phyllite, then schist, and then gneiss. And why does it happen? First, the rocks that are present in the initial conditions, that is slate or phyllite, they will be present at or they will be metamorphosized at a lower temperature. Whereas for gneiss, it will be metamorphosized at a higher temperature. Okay, yes, dynamic one causes foliation. Yes, and another thing also I wanted to add, that metamorphic rocks, they will be either foliated or non-foliated. Very good. Foliated or non-foliated. Example of non-foliated rocks in the chat box. Example of non-foliated rocks in the chat box. It is marble or quartzite. Okay, marble or quartzite, these are non-foliated and the rest are foliated. So these some things you should remember. You can also remember the nature, that is the conglomerate one. For the sedimentary one, it is detrital. Okay, forms breccias, and then so these small things. Or sandstone is also called as arkose when we have a great quantity of quartz, okay, and fields predominating, then it is called arkose. So these some small things you must remember. All are given in which book? I am also referring to that treatise. Okay, all are given in treatise. Okay, now coming to the next part. So this table, easy, no worries. So this is the entire cycle of the rock. You can just refer to it. How are all these different kinds of rocks formed? We'll just move. So we will come to minerals. So minerals are what? Minerals are also naturally occurring. But the basic difference between rocks and minerals is that, ma'am, non-foliated is anthracite and amphibole. No, actually, Rakshita, this anthracite and amphibole, these are minerals. These are not rocks. So you cannot confuse between rocks and minerals. Okay, these are all minerals. When we will read about quartzite and marble is non-foliated, right? But these are all minerals. Building blocks of rocks are minerals. Yes. So coming to the minerals, as I was saying, that they must be homogeneous, number one, and they must be crystalline. So that is a basic criteria, that the minerals must be crystalline. But while reading, I think you have come across that there are several minerals that are non-crystalline. So they are called amorphous minerals. And the minerals that do not show long range order in 3 dimensions. So to be crystalline, they have to show what? Long range order in 3 dimensions. All the 3 dimensions long range order. But there is another group of minerals which is called paracrystalline, that will show long range order, but it will show that only in 2 dimensions, not in 3 dimensions, and that is why we classify them as paracrystalline, that is somewhat crystalline. So yes, so allophane and imogolite, these two will come within this paracrystalline and amorphous part. In some cases you will find that it is paracrystalline, in some cases you will find it as amorphous, but better to shift it in the amorphous criterion. Basically for the imogolite one, that you can shift it under paracrystalline, and for the amorphous, it is truly allophane. Okay. So these are what are allophane and imogolite. We'll come to that. We are moving away to ahead. So as I said that they must be naturally occurring, they must be homogeneous, they must be crystalline, and they must have a definite chemical composition. Okay, definite chemical composition. Okay, we are moving away to ahead, Pavan. Now, coming to the different types of minerals. So we have primary and secondary. So just remember that whenever we have primary minerals, they will be larger, coarser in fraction. And whenever we have secondary minerals, they will be smaller in fraction. And the primary minerals, they will be formed in the initial stage of rock formation, that is at a high temperature and high pressure. See, confined to coarser fractions, and the secondary minerals are confined to smaller fractions. Whenever you will read the soil chemistry, then you can identify these different kinds of minerals, their classification. So I will not be covering the mineral classification and the type here, but I will just give you a brief idea. So for that we have primary minerals and we have secondary minerals. So within secondary minerals, and these are minerals I am writing. So minerals may be your essential minerals and accessory minerals. So minerals may also be essential and accessory. So all this primary and secondary, they are actually included under essential minerals. Essential means they will form chief constituents. They are the chief constituents of rocks. And we have accessory minerals that they are not the chief constituents of rocks. They just form or contribute very little, okay, compared to that of essential ones. Now, primary minerals are those that are larger in size, dominating the coarse fractions. And secondary minerals, they can be divided into secondary clay minerals, that is, true clay is there, because clay has a diameter of less than 2 millimeter, right? So, it is true clay, and the other is clay sized fraction. So within that clay size fraction, their size range will be less than that of clay, but they will not possess true characteristics. For example, if you have quartz, okay, or feldspar. So quartz, feldspar are examples of primary minerals. They have been fragmented, okay. They have been fragmented in a physical, in a weathering condition, suppose where there is very less precipitation, there is high temperature, so physical weathering is there. So in that case, because the quartz cannot alter to form or give something new, it will just break in size, and that will come under the secondary clay sized fraction. Non-silicates are least stable due to shearing of tetrahedral oxide. My god. Okay. They are moving away to ahead. Now, coming to the different classifications of the silicate minerals, these are all we are classifying primary minerals, okay? Neso, soro, cyclo, iono, philo, tectum. It is there. This chart is very important. So we will classify the minerals based on what is the silicon is to oxygen ratio and what is the rate of shearing of oxygen between two silica tetrahedra. So you see that for the first one it is a single silica tetrahedra, and that is why they are also called island silicates. Island, why? Isolated groups are there, no sharing. So because they do not have any sharing, their stability will be very less. So olivine, phyllite, forsterite. So this phyllite is iron mineral and forsterite is magnesium mineral, okay, of olivine. And please remember the chemical formula, that is SiO4 4 minus, okay. Then for the sorosilicates or pyrosilicates, these are double island. Why? Because they are sharing two silica tetrahedrons and their ratio is 2:7. That is 2 silica is to 7 oxygen. So who can tell me what is the charge? What is the charge of Si2O7 in sorosilicates? So this charge actually, the charge that is generated by the silicate minerals, it is called residual charge. What is it called? It is called residual charge. This charge that is generated is called residual charge. The charge left after shearing, whatever is left after shearing is residual. So that is called residual charge. So it is Si2O4 Si2O7 minus 6. You guys are correct. Okay. Next, cyclosilicates means they will form a cycle shaped arrangement, and it is generally 1 silica is to 3 oxygen. Okay, so what is the basic formula? What is the basic formula for cyclosilicates? I'll just write it here. What is the basic formula of cyclosilicates? If I take Si6O18, then it will be minus 12. Okay, so SiO3 minus 2 to the power n. SiO3 minus 2 to the power n, and n is the number of silica atoms over here. Then within the ionosilicates, they will be just chain type of silicates. Either they can be single or double. Single chain pyroxene, double chain amphiboles. Within that, we will also have several pyroxenes. Along with that, we will have pyroxenoids. Okay. And within the pyroxenoids, we have two very important minerals. One is rhodonite and the other is wulfenite. Okay. So this entire chart along with the different minerals, okay, it is given in the old IAAS or any basic standard soil science book you can clarify, but you have to remember or memorize the names of the minerals associated with the different silicates. Very, very important. Okay. Next, coming to phyllosilicates, so that is our concern. Wulfenite is molybdenum containing and rhodonite is wulfenite as well. Rhodonite is what containing? Okay, they said that wulfenite is molybdenum containing, so rhodonite is what containing? Tell me. Now, coming to the phyllosilicates or sheath silicates, yes, it is manganese mineral. Now, coming to the phyllosilicates, this is where our concern will lie. So, whatever clay minerals we will see, all will belong to phyllosilicates or sheath silicates, and they will form honeycomb-like structure, and their basic structure is Si2O5. Si2O5. Okay. Now, mica, montmorillonite, all that. Now, tectosilicates or network silicates are because they have for a 3D framework, okay, where each and every oxygen is shared. So, there are 4 oxygen. So, each and every oxygen will be shared by 4 adjacent tetrahedra. So, that makes the structure very robust. So, for example, quartz or feldspar, they will fall under this group of tectosilicates or zeolites. Quartz, feldspar, zeolite, then orthoclase, nepheline, all these minerals will fall under this tectosilicates or network silicates. Okay, so this was just a basic or a brief overview regarding the different silicate minerals, but you have to memorize the residual charges, you have to memorize the formula in which order the stability of the minerals increases or decreases. That is also very, very important. We are not concerned with ZPC right now. Okay, one important thing is that, can anybody tell me that mica, it is a primary mineral or a secondary mineral? Mica primary mineral or secondary mineral? Mica is primary mineral or secondary mineral? Yes, so mica is a primary mineral, but often we get confused because mica forms chlorite, which is a secondary mineral, or we have also read that black mica is biotite and white mica is muscovite, right, in the clay mineral series. So, please do not forget that mica is a primary mineral, but when the mica will weather, then it will form the chlorite and all the other secondary clay minerals. So, these are all the structures of the different silicates. Please see it once for your reference. Now, coming to the weathering of rock. So, we have the basic constituents for the soil formation. One is rock and the other one is mineral. Now, we will see that how soil is formed. We are concerned with pedology, right? So, we will see that how the weathering of rocks will bring about the formation of soil, because they need to weather, they need to deposit the minerals. Yes, primary. Now, weathering of rocks, never forget that whenever we are talking about physical weathering, it will only involve disintegration. But whenever we talk about chemical weathering, it will involve both disintegration as well as decomposition. So, do not forget that. And in physical weathering, that means it will be brought about by physical parameters, temperature, water, ice, wind, all these are biotic agents. So, there will be no change in the chemical composition of the rock. So, what will change? Either there might be the abundance of water, 1 or 2 water molecules might change, or the structure might degrade and it may become a secondary mineral from a primary one. But okay, onion type weathering is caused due to diurnal changes in temperature. Yes, I'll come to that, just wait. So, temperature, first temperature is a basic criterion, and within that, never forget that even if, because a rock is basically polymineralic. Polymineralic means it is composed of more than one minerals, and there are also several rocks that are monomineralic. Can anybody give me example about monomineralic rock? So, it is actually olivine and dunite. Olivine and dunite, these rocks are composed of a single mineral. Even though they are composed of a single mineral, their thermal expansion along the 3 dimension, it will vary with temperature. So, that will cause about the weathering. And if the rocks are composed of more than one minerals, then also because of the different chemical composition, their thermal expansion rates will differ, right? So, yes, olivine and dunite, very good. So, olivine is triclinic or monoclinic? Olivine is triclinic or monoclinic? That also comment in the chat box. So, this is why the temperature will be a very important factor in governing the physical weathering. And it might be due to exfoliation or onion type when the different expansion gradients will peel the outer layers of the rock and it will lead to the formation of a spheroidal rock. Types of olivine based on yes, but I am asking that whether olivine is monoclinic or triclinic. I want the answer in the chat box for all of those who are watching the video right now. Now, this is temperature. Next will be the action of water. So, all this water and temperature can act in a combined form, right, in the form of ice. So, yes, so olivine is actually your monoclinic and the dunite is triclinic. Are you sure about that? Does everybody agree? Okay. So, see that temperature can also play a basic role in the formation of ice. So, whenever water freezes to ice, its volume will increase and the density will decrease, and due to the increase in volume, it will exert a pressure of 1465 tons per meter square or 150 kgs per centimeter square. So, that you can also convert into foot's unit. Okay, same, it will come same. So, this is the amount of pressure that is exerted if the water is converted into ice, and that much huge pressure will be evidential in breaking that rock or fragmenting that rock. Then water is there, the transporting capacity, it will vary. Then ice is also there, wind is also there, and remember that mushroom kind of rocks are formed due to wind erosion in the Aravalli hills of Rajasthan. I am not explaining, I am not going into too much details because all these are basic, okay, and I think you understand the different agents of weathering. And coming to the chemical weathering, so this is very important. Chemical weathering is a decomposition process. So, if the physical weathering will take place in suppose areas where temperature is very high, precipitation is very low, then the chemical weathering will take place in humid tropics. Okay, and chemical weathering is the most favorable process for the formation of soil because until and unless the rock weathered, then we cannot in terms of monoclinic and triclinic. Okay, so if what I was saying that if the weathering does not happen properly, then we are not going to get a good quality of soil or soil. So, this chemical weathering process is governed again by the different constituents of the water as well. If the water contains dissolved carbon dioxide, if the water contains dissolved salts, acids, all that will aid in chemical weathering. So, these are the most important processes of chemical weathering. Remember those along with the examples, okay? Remember those along with those examples. So, first is solution. So, whenever we talk about solution, it is something related to water. It is something related to water or how does the water make all that element soluble and why? Why does water, why is water considered as a universal solvent? Because it has a very high dielectric constant, and that too about 78.5 to 81. Because water has this high dielectric constant, it can easily dissolve any substance that is polar in nature. So, the easily polar molecules or dissociable molecules, they will rapidly dissolve and they will ionize. Now, coming to hydration. So, hydration is nothing but here the water will be as an entity, that is H2O only, and it may either accumulate in the outer surface of the rock, okay, or mineral, and it might lead the mineral to expand or become soft and readily weatherable, etc., etc. But one thing for hydration, that is the water will never dissociate. It will not dissociate into H plus and OH minus. It will not do that. Whenever we come to hydrolysis, that is the second or third chemical weathering process, in that case the water is going to dissociate into H plus and OH minus ions. Okay. So, these are some of the examples of hydration. Hematite to limonite. Limonite is also called bog iron. So, I think you are okay with this. Now, coming to the most important process, which is hydrolysis. So, in hydrolysis, the water will actually dissociate to form the H plus and OH minus ions, and these H plus ions formed by the dissociation of water, they are very active weathering agents. Okay, and hydrolysis is also called double decomposition, or it is called the forerunner of clay formation, because after the hydrolysis of the primary minerals, you see these are all the primary minerals, KAlSi3O8, HAlSi3O8, these are all the primary minerals, and after the hydrolysis of primary minerals, you are getting either the secondary minerals or you can get kaolinite kind of clay. Okay, so this you have to keep in mind, that hydrolysis is the most important process, but it will be most important for what kind of mineral? For primary mineral, rightly said in the chat box. And hydration, this is the most important process for secondary minerals. So, never confuse in between those. Next, fourth process is oxidation. Very simple. Oxidation means addition of oxygen or loss of electrons. Addition of oxygen or loss of electrons. Okay, addition of oxygen or loss of electrons, it will be there. Just a second. Okay, so addition of oxygen or loss of electrons will be there. So what will happen in case of oxidation? The oxidation number will increase. Okay, so suppose we have magnetite here. In magnetite, what is the oxidation number of iron? Please comment. In magnetite, what is the oxidation number of iron? So the oxidation number of iron in magnetite is, iron is in which state in magnetite? So this is +2, ferrous state, right? And in case of hematite, what is the oxidation state of iron? Please comment in the chat box. Whenever we will have oxidation, there will be an increase in the oxidation number. So, the ferrous iron, that is, ferrous iron is +2, it will get converted into ferric form, that is +3. Okay, so that you have to keep in mind, that in oxidation, magnetite is converted to hematite, but not the opposite. The opposite one will happen in reduction process. Okay. Then coming to carbonation. So, carbonation means there will be the formation of carbonic acid, a weak acid. Okay guys, comment that if the partial pressure of carbon dioxide increases, then the acidity will increase or decrease. Acidity will increase or decrease. If partial pressure of carbon dioxide increases, yes, you guys are all right. If partial pressure of carbon dioxide increases, then acidity will increase or decrease. Please comment in the chat box. So, this carbonation, whatever carbonic acid is generated, because it is acidic, acid aids in dissolution of minerals, and it will dissolve the insoluble calcium carbonate to the soluble calcium bicarbonate, and that can again aid in the decomposition process. Yes. So, whenever the partial pressure of carbon dioxide in any system will increase, then the acidity is bound to increase in that system. Got it? So, this is why carbon dioxide also is a very, very important factor. Now, these are some of the lines written that I had already explained, that is most important chemical weathering process for the primary minerals, for the secondary minerals, do not skip it. Sorry. Coming to the third one, that is biological weathering. So, biological weathering, it is a combination of physical and chemical weathering, but that is brought about by biological organisms. Fine. Now, first physical and chemical weathering will happen, and then biological weathering will happen. And here one term is very important, the prying effect. So, this prying effect is brought about by, I am giving you three options. One is roots, the other is microbes, and the other is man. So, the prying effect is brought about by, comment in the chat box guys, the prying effect is brought about by which? Roots, microbes or man? in case of biological weathering, because this is a very, very important term, the prying effect. Okay, comment in the chat box. Okay, I am waiting. Now coming to pedogenesis. So I will be waiting for the answer. Okay, coming to pedogenesis. So pedogenesis is the formation of soil, as I had mentioned. So within pedogenesis, two factors will be there. One will be the soil forming factors and the other will be the soil forming processes. So why am I not getting any comments? That is, the prying effect is due to, ma'am, you take classes every day. Not every day, but regularly we arrange classes over here, and if you are a JRF aspirant preparing for physical science, you are welcome in my class. Whatever doubts you have, you can get it solved over here. Okay. Now, this prying effect is actually brought about by roots. Nobody commented the answer. The prying effect is actually brought about by the roots, and with this prying effect, because when the roots will grow into your soil, that will exert some kind of pressure, and that pressure will fragment the rock. So it is indirectly a process of biological weathering. Never forget that. Now coming to pedogenesis, as I was mentioning, we have two things: pedogenic factors and pedogenic processes. So how does the formation of the soil take place? First you have rocks or minerals, and then they will undergo weathering. Okay, they will undergo weathering, and then they will form some sediments, and that sediments we can call it as regolith. And when the soil forming factors and processes will act on this regolith, then it will form the solam or the true soil. Solam or the true soil. So often people get confused between these terms, what is regolith, what is solam. We will come to all of that later. But remember that regolith is whatever the weathering agents are bringing down to you, and it is unconsolidated. It is unconsolidated. And then on that, the soil forming factors and processes will act, and then it will lead to the formation of the true soil or the solam. Okay. So this concept that how the soil is formed, ma'am, unconsolidated material above bedrocks will be called regolith. It is called whenever there is unconsolidated material above the bedrock, it will be called as regolith. Yes, because we will come, when we will come to regolith, then you will understand. Okay. Now coming to the different soil forming factors, initially the different scientists gave soil as a function of different factors. So first one was Dokichev, and he said that soil, it is a function of parent material, climate and organism, PCLO, and he gave this equation in 1889. Then Jenny came, and he in the year 1941 said that the soil will be a function of climate, biological organisms, relief, parent material and time. 5 soil forming factors he gave, and we till now follow this Jenny's model. Then there was another scientist whose name was Joffe. Okay, just a second. Then there was another scientist whose name was Joffe, and he in the year 1949 actually divided the factors into active and passive. So what are active factors? Active factors will be those that will act on the soil forming mass, and they will bring about the chemical changes. So they are actually the driving force. Joffe brought active passive. Yes, yes. Okay. Now passive factors will be those that actually provide the mass on which the active factors will act. For example, parent material. Without parent material, will the active factors be able to act? No. So it will form the mass of the soil forming material, and active factors will provide the energy or the driving force. Fine. Now within the passive factors, we have parent material and time, and within active factors, these 3 factors are very, very important: climate, biosphere and relief or topography. I think the relief or topography will come in passive factors, no? not the active one. Climate and biosphere are active, but this relief or topography will come in the passive one. Okay, sorry for the mistake. Now, see, first is climate. This is the most influential factor, and two things are there. One is temperature and the other is precipitation. Temperature and the other is precipitation. And in different kinds of climates, generally in case of humid tropical climates, there will be more rate of weathering. So, that will dictate the type of soil that is formed. Okay. Yes. So, it will be, please do not get confused, the relief or topography will come in the passive factors. Then, coming to the organism or biosphere. So, different organisms will be there that will aid in biological weathering. But one thing I wanted to just clarify, tell me, if we have macroorganisms and we have microorganisms, we know that biological weathering is happening, so soil is forming, but which of the following organisms will retard the soil forming process? Retard the soil formation. Macroorganisms or microorganisms which will retard the soil formation. Ma'am, passive factor is the skeleton part. Yes. No, actually macroorganisms will retard the soil formation, not micro. Why? Because macroorganisms, due to their burrowing activity, they will intermix the different soil profile there. So, there will be no horizonation. But microorganisms on the other hand, they will aid in the process of soil formation by the formation of different other secondary products or residues. But macroorganism, because of their pedoturbation movement, I will write it down, because of pedoturbation movement, they will disturb the horizonation sequence in our soil. Okay, not yeah, macro, yes, not micro. Now, coming to the third point, that is relief or topography. So, I am not actually going into details with each and every factor because then it will take 1 hour. Okay, coming to relief and topography, it denotes the configuration, and guys, you also have to remember what is the percentage of relief. Okay, so just be with me. So, we have 0 to 2%, that is flat. Then we have gently undulating, right? Topography, broad term, relief, narrow term. Yes. So, flat, then gently undulating, then undulating, then rolling. Okay. Then hilly or steeply mountainous, whatever. So, with that, you also have to remember the percentages of slopes. Okay, percentages of slopes for each and every factor. So, who can comment? So, who can comment what are the percentages? This is your question. Comment on the percentages of the different topographic factors. Okay, this is your question. I want the answer in the chat box. Okay, moving to our next factor, we have the parent material. So, according to parent material, it is the mass of soil formation. Okay, 0 to 2, then hilly 15 to, I want it sequentially, what I wrote. Okay, sequentially, whatever I wrote. So, parent material, if your parent material is basic, then the soils formed will be basic, simple. If your parent material is acidic, then acidic soils will be formed. So, it will depend on the type of parent material, the nutrient content of the parent material. Okay. So, flat is 0 to 2, gently undulating is 2 to 5, undulating is 5 to 10%, okay, rolling is 10 to 30%, and whenever it is hilly, then we have greater than 30%, but the slope height will be less than 30. Okay, no, slope height will be less than 300 meters for hilly, and for steeply mountainous it will be greater than 300 meters. Okay, but for both the cases it will be greater than 30% slope. Okay. Now, coming to our next factor, that is time or age. So, this is also called pedologic time or pedological time, and there is a question for you that How much time is taken by soil to form 1 centimeter? 1 centimeter of soil formation takes how much time? The answer is 200 years. So 200 years under ideal conditions of all the other soil forming. No, it is 800 to 1000 uh, for you can say the climates where the weathering is not favorable, but ideally it will take 200 years for chemically favorable climate. Okay, not 800 to 1000. Now within time, I wanted to tell you that there are different stages of weathering, and that stages of weathering, they are given by Moher and Van Baren, right, in 1954. So they gave the different stages of weathering. And what are the different stages of weathering? Initial, juvenile, virile, senile and final. Fine. So remember, the most important stage is our virile one, where the clay content of the soil will increase. So this part you only have to remember. For the rest, you can go through that. Initial means there will be no weathering, weathering hasn't started. Juvenile, only the highly weatherable minerals have weathered. Then virile, senile and final. So final means the weathering has concluded, and in case of virile, there will be an increase in clay content. Okay, fine. So this is related to time as a factor. Okay, now a bit of promotion time. So as sir rightly mentioned that we have launched our batch, that is 2026 target batch for JRF, and those of you guys who haven't joined that, you can still access it at a much lower price. And if you want the PDFs of all this marathon series and most expected ones to be uploaded, you can join the test series, or you can even join our batch where all these things are explained in details. All of these are explained in details. Now, there are different weathering agents. This is also very easy. Depending on the weathering agents, we can name our parent material. So, for colluvium, it is gravity, alluvium, it is river water, aeolian, it is sand. Whenever it is lowest, the parent material will be silt, but whenever it is aeolian, it will be sand. Then we have lacustrine, organic, outwash residuum. So, I'll just go out of the frame so that you can take a look, and then we will continue. Okay, fine. So these are the elevation percentages that we had already studied, that what are the percentages of elevation, and this comes under relief or topography. Now another important thing is that regarding relief or topography, there were two scientists. One is Catena. This Catena concept, it came in the year 1935, and Milne was a scientist who actually gave the concept of catena. Soil fluxion, parent material, yes, and he said that the soils that have similar kinds of parent material and all the other soil forming factors, but only differing in this relief or topography, will be present or will have different properties, and that is attributed to this term called catena, or that is attributed due to the changes in the hydrology due to relief or drainage due to relief. And there is another term called topo sequence. So this topo sequence is similar to catena, but here they have only considered the morphology of the soil, that is color, but they have not considered the hydrological properties. Yes. So topo sequence and catena are a bit different from each other. In topo sequence, only morphological parameters, but in catena, all processes of erosion, transportation, sedimentation and hydrology, it is involved. Now, factors are done. Coming to the different soil forming processes. So, who gave this fundamental pedogenic process concept? So, this was given by Simonson in the year 1959. And he said that there are three fundamental pedogenic processes: humification, formation of humus; alluviation means emigration. So, if you have a soil profile, suppose if you have a soil profile O, A, B, C, R, this is our soil profile. We will come to the soil profile. Whatever materials are present on top of the soil profile, when they get deposited in the lower regions, then it is emigrating out of the system. So, this will be emigration or alluviation. So, the process of washing out is called alluviation, but whenever they are getting deposited, that is called alluviation. So, alluviation will take place here in the A horizon, or we can say E horizon, and the alluviation will take place in the B horizon. Okay. So, never forget this. Simon said. So, this is it. So, another thing is that if the clay migration occurs, if the clay migrates from one part of the profile to another, then it is called lessivage. Clay migration is lessivage, and who gave this term? Who gave this term? Clay migration or lessivage, who gave this term? I want the answer in the chat box. Now, specific pedogenic process will be different from fundamental pedogenic process. How? The fundamental one will be present in all the different soils. So, it will happen all over the world irrespective of the climate or the other factors. But yes, so this was given by Dasha 4. Okay, very important. Now, specific pedogenic process, within that we have calcification, that is accumulation of calcium carbonate. Accumulation of calcium carbonate at a high temperature, and PCO2 will be less, partial pressure of carbon dioxide will be less. Decalcification, just the opposite of calcification. So, this generally happens in arid and semi-arid region, the calcification. Then podzolization and laterization, these two are very important. So, I will explain it to you. In case of podzolization, it is called acid hydrolysis. Okay, acid hydrolysis, where the silica will remain on top, but the sesquioxide, that is Fe and Al oxides, they will get leached out of the profile along with the basic cation. So, this podzolization is also called silication, and this will happen with acidic kind of parent material and cold humid conditions. But just reverse this. Make the conditions warm humid. Parent material is also basic. So, in that case, the silica will leach down. But the sesquioxides, when they remain on the profile, then it is called laterization. And this is alkali hydrolysis, not acid. This is alkali hydrolysis. So, this is the basic difference between laterization and podzolization. So, the difference will be in the parent material, in the climate, in the type of vegetation that is there. In case of laterization, generally you will find forest vegetation is there, but in case of podzolization, coniferous vegetation is there, conifers, that will be there. So, that is the basic difference between laterization and podzolization. Now, these are two most important specific pedogenic processes. Glycation is the formation of gly. Gly is a reduced iron layer, that is blue or grey in color, and that happens generally in waterlogged conditions. Salinization, accumulation of salts. Alkalization or salinization, accumulation of sodium. Dealkalization is when the sodium clay is getting hydrolyzed. Ma'am, warm humid is in ladder. Yes, horizonation is fundamental process. No, horizonation is not a fundamental process. According to the fundamental process given by Simonson, there are only three: humification, alluviation and alluviation. Horizonation is not a process. Horizonation is the consequence of the process. It is the effect. These are the causes, horizonation is the effect. Then pedoturbation is the mixing. Pedoturbation is the intermixing of the different layers in soil, and lessivage, I mentioned, it is clay migration. So, all these three: salinization, alkalization, dealkalization, glycation, you will read in details in the waterlogged soil or problematic soil section, that will also be included in our marathon series. So, I am not actually including this in details. Now, within pedoturbation, as I said, it is intermixing. It can be of different types. Cryopedoturbation due to temperature, argilopedoturbation due to clay. You can get all these details, but I am not covering those. I am just, briefly telling you all this. Now, coming to the weathering sequence of minerals. So, we are saying that, okay, rocks and minerals will weather. Ma'am, fundamental pedogenic process is given by Simonson, then basic pedogenic process is. Okay, okay, okay. Yeah. So, see, yes, okay. So, Simonson actually gave the basic processes. Yes, you are right. Simonson actually gave the basic processes, but the fundamental and yes, that's it. The fundamental and specific pedogenic processes, they will happen in all the different soils, but the basic pedogenic processes were given by Simonson. Yes. Oh, thank you. Who is it? Picasso or something. Yeah, thank you so much. Basic pedogenic processes were given by Simonson. Fundamental and specific, later on scientists actually discarded these basic processes. Now, coming to the weathering. So, weathering sequence of minerals. So, we are saying that okay, rocks and minerals will weather, but what is the sequence of their weathering, that we have to understand. So, accordingly, we have Goldrich stability series. So, before Goldrich stability series, there was a scientist called Bowen. And Bowen said that I will say what is the order of crystallization of the mineral. What is the yes, Rakshita, you guys are all right. I'm sorry. So this Bowen's reaction series is actually based on crystallization. Based on crystallization of the minerals. That is, in which orders the mineral will crystallize, and this is similar to Goldrich stability series, only the term or the terminology given is different. He said that the minerals that are present in the lower level of the series, they will crystallize last, and whichever minerals crystallize last, they will be most resistant to weathering. But Goldrich stability series says that when we go down, the stability of the minerals increases. And there are two series. This one is our discontinuous series. Discontinuous series of minerals, and this one is our continuous mineral series consisting of different feldspars. So, whenever we have anorthite, it is a calcium feldspar. Then bitumenite, labradorite, andesite, all are mixture of calcium and sodium. And finally, we have albite. So, this entire first series of feldspar, it is called, discuss please ma'am, basic. Okay, coming to that. First, let me discuss this. So, this feldspar is actually, first is anorthite, then bitumenite, then labradorite, andesite, oligoclase and albite. So, albite is a sodium feldspar and anorthite is a calcium feldspar. This entire series of feldspar is actually called your okay. So, this potash, we have two different kinds of feldspars. One is orthoclase and plagioclase. Plagioclase is also called oligoclase. So, plagioclase are K feldspars or potash feldspars. So, this will be plagioclase. And all of these are actually your orthoclase. Okay. So, this is the continuous series of minerals and these are the discontinuous series of minerals. You see that quartz is coming at last because quartz is a tectosilicate. So, it will weather last. I will come to that because now, so from the stability series, you have to remember the stability series along with all the minerals that are present. So, from the stability series, what is our conclusion? Least stable is olivine, most stable is quartz, and this is the order of stability of the different minerals. Now, coming to another thing, okay. So, similar to the Goldrich stability series, we have another thing, that is weathering index. Weathering index of the minerals. And this weathering index of the minerals, it was actually given by Jackson in the year 1964. Jackson in the year 1964 gave the weathering index of minerals, and accordingly he assigned different numbers to the minerals, starting with calcite, okay, or gypsum, this group. 1, 2, 3, 4 like that. He gave the orders and he said the mineral containing a greater order or a higher number, it will be more stable or it is at a highly weathered stage. Okay, so this Jackson's weathering index also, it is very important. Please do remember the names of all the minerals and at what index they will come. Only I will tell you that kaolinite is the most or it comes at, I will say that it comes at the last stage of weathering for clay, silicate clay. So, kaolinite is the clay that is present at the last stage of weathering. So, after all the weathering processes have been completed, we will be left with kaolinite. Now, coming to your question, what are the basic fundamental processes that we also have to mention? Basic fundamental processes. So, these were given by Simonson. And within the basic fundamental processes, and it is 13 also, okay, if any, also known as rutile, if in, okay, ma'am, weathering index which is related to topic. I could not understand your question. Plan with concept. Gypside, calcite, olivine, battered. Okay, fine, very good, very good. Okay, coming to the basic fundamental processes. So these are addition or gain. Oh, I'm really unlucky.
In camera, we will continue tomorrow.
Tomorrow,
Class continue. You can see.
let's see.
All things are working.
Oh, see, I am not that unlucky.
Forward.
You can sir come and do that. Sorry, you are laughing.
एक मिनट.
Yeah, sir. Yeah, God is with me. बार बार मेरे साथ ऐसा क्यों हो रहा है?
Guys, 2 minutes. Okay, just bear with me for 2 minutes. Just wait for 2 minutes. She'll come and start. थोड़ा आज पावर कट का इशू चल रहा है. अच्छा हुआ एटलीस्ट सिस्टम में यूपीएस है. एटलीस्ट आपके लाइव बंद नहीं हो रहे हैं. Which slide you were?
Which slide? No. My God, so much is left. This one.
Okay.
Okay. So sorry again for the interruption, guys. Am I audible? Am I audible? Okay. Sorry again for the interruption, but I think that God is with me today. So let's continue. Interrupted twice. So, see, we were talking about some basic processes, basic weathering processes, basic soil forming processes that were given by Simonson. And we have addition, okay, or gains, then losses, then transformation and translocation. Okay. Addition or gains, losses, transformation and translocation. So he hastily classified the different soil forming processes, and he said that addition means whenever we are inputting something from outside in the soil. Losses means it is leaching and all the other losses of weathering. Transformation is one mineral to the other from primary to secondary, secondary to humus, and translocation is elevation and elevation processes. Okay. So now coming to the next part. Now, soil is formed, fine, with all the soil forming factors and processes. Now, we have to classify the soil because that also comes under pedology. So, these are the historical developments in classification. The earliest classification systems were economic, based on what is the uh, economic classification, that means how the soil is used commercially. Then physical classification based on texture, chemical classification based on the chemical properties, geological with the underlying geology, and the physiographic classification is characteristics of the landscape. Okay. So, these are just early systems of classification. We should not be concerned with that, but we should be concerned with Dokuchev's genetic system of classification. So, he is the father of modern pedology, and he gave the genetic system. Genetic means genesis, how the soil is formed, right? So, he gave more importance on what are the different soil forming factors and processes rather than what is present now. Okay. So, you see that he first gave the concept of zonality. We will come to that. Dokuchev was the first one who gave the concept of zonality, and he said that based on the different soil forming factors, we can classify the soils to be normal, transitional and abnormal. So, he first did not coin the term zonality, but he divided the soil into three parts. So, normal means that they are formed due to action of the environment is there, that is in good or proper weathering conditions. Transitional means in specific climates like that of hydromorphic or halomorphic soil, and abnormal means where only the parent material is the dominant factor, okay, in the soil formation. And later on these categories were renamed as zonal, intrazonal and azonal. We will come to that. But after Dokuchev, Marbut gave his morphogenetic classification systems. He said that not only on the genesis but also now what is the morphology of the soil, we can classify them. And he is actually called as the American father of pedology. American father of pedology. Okay. And he gave two most important concepts. One is the pedalfers and the other is pedocals. Wherever there is ALFE, pedalfers means aluminium and ferrous are present. So, these pedalfers will be those that are rich in iron and aluminium. And just imagine, I told you, in case of laterization and porzolization, what was happening? Rain was leaching them all down, right? So, these are the extreme soil forming processes where the sesquioxides oxides are retained and all the other basic cations are leached away. So, the pedalfers will be formed under highly tropical conditions. So, if intense weathering has happened, then pedalfers will be formed. If the weathering is not that intense, then pedocals will be formed. And pedocals, they are calcareous or calcium rich, you can say. Clear? Okay, Marbut added great soil groups. Okay, fine. Next, Baldwin and Associates. So, what did they do? Their main contribution was they just declined Marbut's morphogenetic classification and they added a new thing called the soil family. So, all these different classification systems that we now see, the orders, suborders, they all were a product of different classification systems, not only one. So, the major limitation was that it was based on the soil genesis, because although his name was morphogenetic, but he emphasized more on genesis, how they are formed. And the morphogenetic system was revised and elaborated by Baldwin and Thorpe, and these are the salient features. So, Marbut actually excluded zonality. Baldwin and Associate increased the syllabus. Yes, they did. So, they actually returned to the concept of zonality. Pedal for pedocal concept was de-emphasized and more emphasis was laid on soil as a three-dimensional natural body. Okay, so it should be three-dimensional natural body. So they gave more emphasis on that. And in Dokuchev's genetic system of classification, we did not consider the cultivated soils. They only considered the virgin soils where there were no cultivation, no anthropogenic effects. But we should not be concerned with that, right? We should be concerned with what the present state of our soil is. So that was a limitation of the genetic system of classification. Now, this is the entire chart of the soil classification, and we will have different orders. So this is a hierarchical system. Orders will be at the top of the umbrella, and there are 12 soil orders. And we can remember it with the help of a small mnemonic, which is Avagami house. Avagami house, okay. These are 12 soil orders. Then we have suborders. So as you go down, the similarity will increase or decrease. As you go down the series, the similarity will increase or decrease. Comment. Increase or decrease. Comment on the chat box. As you go down the series, the similarity will increase or decrease. Next, there are 12 orders, as I had mentioned. All these orders you should remember by name. And out of these 12 orders, 5 are not found in India. Only 7 orders are found in India. So, what are the orders that are not found in India? It is GHAS. So, you can remember it by that. The jelly salts, the histosols, the andisols, the spodosols as well as the altisols, all these 5 orders, they are not found in India. Okay. As we go down the series, it will become more specific. So, the similarity will actually increase and the dissimilarity will decrease. Okay. Now, previously, we had only 7 soil orders, but there was a recent addition and they had added the jelly salts and the andisols, and now we have total 9 soil orders. So, this is an important question. In India, how many soil orders are there? Previously, how many soil orders were there? Total, how many soil orders are there? You should be very clear with that. Now, so the highest category, as you can see, is order, then suborder, grade group, subgroup, family, series, and finally, we can have another line with soil type. Okay, soil type, but that is not included in the taxonomic system. So, the heading is what? Taxonomy. Taxonomy means nomenclature. So, we have classified the soil and then we will name it. Okay. So, these are the descriptions of all the categories. See, order. It is based on morphology. Presence or absence of major diagnostic horizons. So, how can you determine the order? By the presence or absence of major diagnostic horizons. Then suborder. Suborder is, they will be a bit more based on the environmental factors, the genesis, climate, blah, blah, blah. Then the grade soil groups. So, grade soil groups are, they will emphasize on the diagnostic subsurface horizon. So, this is surface horizon in case of order. In case of grade group, it is subsurface horizon that is present inside the surface. Then, subgroup is, it has been classified into 3 types: typic, intergrade and extragrade. Typic means central concept of grade group. Intergrade is that if you cannot place your soil in a particular subgroup, then you can say that it is intergrade, the intermediate of 2 or more subgroups. In case of extragrade, if you cannot even find a position to place it, then you will say that it does not belong to any of the subgroups. So, you can say that it is extragrade. Then in case of family, so family, it is used for making practical prediction for land use planning. Soil temperature and moisture regimes, they will come at family level. So, whenever you classify the soils with temperature and moisture regimes, say 63 or 64, it will be in the family level only. Then series. So, series is used for the preparation of your soil maps because it is the lowest one, and here it has differentiating characters like color, texture, structure, consistency, all that. It has no pedogenic significance. No pedogenic significance, but only used for the formation of soil maps. Okay. And whatever terms we had mentioned so far, order, suborder, grade group, subgroup, all will be included under taxon. So, all you can collectively call that they are taxon or taxa, okay. And it is a class at any taxonomic level. So, if I say that whether or not order is a taxa, you will say yes, suborder is also a taxa. So, all of these are taxons or taxa, it is plural, and the nomenclature, it is mostly based on coined words from Greek or Latin languages, okay, Greek or Latin languages, okay, fine. Now, very important thing that whenever you are reading orders, please do read the meanings of the names or prefixes of the orders. You can find it in any standard book, Gold IEEE, but you have to read the meanings of the orders as well. Now, this we had already covered. What are the different types of soil orders and who gave them by DocuChef? You just see once. And most important thing in this entire slide is that in what kind of soil. See, in case of azonal soil, we have no suborder. So, question might come like they can include regosols and they can tell you that in which order of zonality do they belong. And then you will have to mark that whether or not they are azonal, infrazonal or zonal. So, in zonal, we have total 6, in intrazonal 3 and in azonal no suborder. Okay. So, that you have to be very careful. Now, so this is the soil profile. So, finally, we have reached the soil profile. These are the different horizons. Now, what is the difference in between a profile and a horizon? So, profile is nothing but it is the vertical sectioning. Okay. And so, if I consider this vertical sectioning, then this is called a soil profile. And if I consider the horizontal sectioning one by one or the horizons, then these will be horizons. So, within one profile, numerous horizons will come. And the profile is essentially two-dimensional. Profile is essentially two-dimensional. Yes, 12 orders are there, fine. So, what are the profile, what are the different horizons? Let us see. First is O. So, here you can find it. O, it is dominated by organic material. So, generally this O horizon is not found in cultivated soil, it will be only found in the soils that are in forests. So, it is absent in grassland. But A, it is your topmost mineral horizon. Then E is the zone of alluviation. Then B is the zone of illuviation that I just mentioned. C is the parent material above which the soil is formed, and R is the bedrock. So, if I combine, see here it is written very clearly. Regolith is A plus B plus C, and solam is only the upper portion of the regolith, that is A plus B. So, do not get confused. This solam is your true soil and regolith is the unconsolidated parent material. Okay, that is comprised of A plus B plus C horizon. Fine, got it? Okay, 7 will be right. Ma'am, how many soil orders found in India in exam? You should write 9. Now it is 9. Okay, if the option is between 7 and 9, please tick 9 because jelly salts and andisols have been included. So, you cannot write 7. Initially, it was 7. So, it should be 9. Okay. Now, we will come into the diagnostic horizons. So, see in the horizonation profile of your soil, you have several master horizons. Master means that I just mentioned O, A, E, B, C, R. Then you can have some transitional horizons. Transitional means either AB or BC or OA like that. So, that means they will be found in transition layer in between two horizons that we cannot differentiate, and then we can have subordinate. So, subordinate horizons means each and every horizon will be assigned a specific letter or alphabet, either A or B, C. So, from A to Z there is a series. Please do remember the series. I have not mentioned the series. LMW means I am not understanding. So, there will be specific alphabets assigned to each and every horizon that will indicate the specific pedogenic process that is undergoing. A stands for highly decomposed organic. Yes, yes. So that chart also, please, from old IEEE, you read it. You memorize the names of all the alphabets given over there. That is very important, the subordinate horizons. Okay. So for the horizonation, we can have two kinds of diagnostic horizons. Yeah, LMW is also there. Yes, yes. So master horizons OAEBCR we can call, but if we include the total, there are 9 horizons. LMW is also there. Don't worry. Also master horizon. Yes, yes. So 9 are there. Not 6, 9 are there. Now, diagnostic horizons, we have epipedons and endopedons. Epipedons will be surface. They are present on surface, and endopedons are present on subsurface. Okay. Epipedons are present on surface and endopedons are present on subsurface, and endopedons are at 15 to 38 centimeter depth, whereas epipedons are 0 to 15 centimeter depth. Okay. Ma'am, SS indicates SS indicates lichen sites only. Sesquioxides, no, it does not indicate sesquioxides. Now, there are 8 epipedons and 19 endopedons. And out of that 8 epipedons, the MOU, molic, ochric and umbric, that is present in, or that is of most importance to us in India. And there are 8 endopedons that you should read. So, argillic, natric, cambic, candic, oxic, salic, calcic and gypsic, all of them are there. So, we will come into that one by one. So, actually, I haven't included all these horizons, their details and descriptions, no. So, if you subscribe to our master course, you can find it there, because explaining each and every horizon in detail will take another 2 or 3 hours that we cannot spare, but we will do a brief revision. Okay. So, for the molic, tell me, for the molic epipedon, actually, the base saturation of this molic epipedon is very high. Umbric epipedon, lower base saturation than the molic. That is, base saturation is not that high. Anthropic means here it is human modified. High percentages of phosphates and all that. Yes, it is greater than 50%. For molic, it is greater than 50%. Anthropic means here it is human modified. High concentration of citrate soluble phosphates will be there. All that. Ochric means low chroma will be there. More than 50 molic, yes, best among all, fine. Ochric is low chroma is there. Melanic means andic properties are there of andisols, volcanic ash, greater than 1% organic matter. Folistic and histic, always remember that it will be associated with the saturation. Folistic will never be saturated for greater than 30 days. Histic will always be saturated for greater than 30 days. And plagen is a horizon that is human made, and it is modified or depicted by the presence of several artifacts. Okay, artifacts are present. So, this is just in very brief about the horizons. For the endopedons, argillic means, argilla means clay. So, there will be clay skins or cutons. Clay skins or cutons. Natric, natrium means sodium. Agric means where agricultural practices are ongoing. Spodic horizons refers to spodosols that are found in high rainfall areas in the tropics. Sombric horizon is there. So, sombric horizon, humus, it is due to the elevation of humus. Then cambic horizon is where there are textural alterations or structural alterations. Candic means low activity clay is there. Oxic means highly weathered. Okay. Sulfuric, from the name itself, sulfuric acid content is there. Salic, saline. Classic horizon is again something that your great amount of iron and manganese is present and it is slowly permeable. Albic horizon is bleached. Glossic horizon, tonguing. That means it will intrude in other horizons. Then calcic and gypsic. So, calcic is calcium carbonate and gypsic is calcium sulfate. Then these duripan, fragipan, petrocalcic and petrogypsic we will be covering. Ma'am, what composting will be in anthropic and manuring will be in plagen? Yes, yes. So, in case of anthropic, it is human made, and in case of plagen, it is human modified. So, these are First, okay, first let me tell you about the juripens and the fragipan. Yes. So, they all are included in other diagnostic soil characteristics other than the diagnostic horizons. Okay. So, first we will have duri nodes. So, whenever nodes means what? Nodulated. So, they will be weakly cemented by silicon dioxide, SiO2. Juripan, this is very, very important. So, they will not slake in water or HCl, but they will slake in hot potassium hydroxide after acid washing. So, that means here your beds will be air dried, but if you apply water to them, they will not dissolve or they will not slake, they will not absorb the water. But if you apply hot potassium hydroxide, then and only then they will absorb the water and they will slake. Okay. Then fragipan. So, fragipan is different from juripan. How? Here they will slake in water. So, in case of duripan, they were not slaking because that was very highly cemented. And in case of fragipan, it is slaking in water because it is not that cemented. And here also we have low chroma models, that is color is low. Permafrost from the name only, that is it is always at a temperature of less than 0 degree centigrade, and plinth height, very, very important, came from the word plinthos or brick, humus pure sesquioxide rich horizon. So, here the elevation of humus will take place from the soil and the sesquioxides will remain on top of the soil. Okay. And that will be associated with repeated wetting and drying. So, if repeated wetting and drying cycles occur, then the humus will be elevated from the soil, your clay will be elevated, and you will be only left with insoluble Fe and Al oxides. Now, coming to the diagnostic organic matter. So, also you can classify the organic matter, but you cannot include it in any horizon. So, the soil classification system can accommodate all the non-soil fragments as well. The organic matter, the durinones, they are all non-soil fragments. But we have also included that because they are an integral component. So, that is one of the advantages of this modern soil system of classification. So, from here the most important thing is that the fibric means peat. Fibric is peat and it has over 2/3 mass consisting of organic matter. That is very important. Then the hemic is mucky peat or peaty muck. So, it is a transitional horizon, 1/3 to 2/3. In case of sapric, this is muck. So, please do remember the terms as well. Ma'am, why is permafrost called permafrost? How can I know that? How can I know that? So, why is your name Chaman Pandey? Tell me. Why is your name Chaman Pandey? So, there cannot be any explanation why that term is included in the nomenclature, right? Okay. You could have asked some more scientific question. Now, sapric horizon is formerly marked. So, you have to memorize what is the name of these different materials and what is the stage of their decomposition and what is the percentage of organic matter that is present in them. Okay, you can say it like that. Now, in case of humi-eluvic materials, humi-eluvic means elevation of humus, and limnic materials, they are hard materials. Okay, limnic are hard materials deposited in water by the addition of organisms. So, you just remember the terms along with the names and what is the percentage of organic matter content in those. Now, these are again some of the specific criterions or specific processes that may happen and that may lead to the formation of a hard soil mass that you cannot term as soil. So, these are for both mineral and organic soils, but this is typically under aqueous conditions. So, aqueous means saturated with water, it will be there. There might be frost churning or cryoturbation, or even there might be densic contact. So, densic contact means whenever your root will come in contact with a layer that is impermeable, it cannot penetrate. So, it can be densic material or gelic material. So, these are all the non-soil or the densic contacts. Okay. The first one is your lithic. Lithic means here whenever we judge the hardness of any mineral, we use Mohs scale. And if there is a boundary between your soil and an impermeable layer and the hardness is greater than 3, then it is lithic. If the hardness is greater than 3, but the material is non-coherent, that means it is non-continuous, not directly in contact with your soil above, then it will be paralithic. So, in both the lithic and paralithic, Mohs scale of hardness will exceed 3, but one is coherent and the other is non-coherent. Fine. Then the roots can penetrate at irregular, because it is non-continuous. Obviously, in case of paralithic, the roots may penetrate in some portions where the hardness is not there, right? Then petropheric. Petropheric is very easy. Soil and in an indurated layer of iron cemented material. Similarly, we can have petrogypsic and petrocalcic. Gypsic means gypsum-like material, calcic is calcium carbonate kind of material. Then when I was talking about family, I said that moisture and temperature regimes, they are also very important because they are included in the soil taxonomy, finally in the family level. So what are the different moisture regimes of your soil? So always remember that because our field capacity to permanent wilting point or the capillary water that is present in our soil, it is in between 33 kilopascal to 1500 kilopascal. Whatever soil moisture is directly related to the plant growth, only that we will consider in the soil moisture regimes. Para always means something lacking. Okay. Now, soil will be considered as moist if you do a sectioning. So, how can you know that whether or not your soil is moist? If you do a sectioning, and that sectioning is governed by soil moisture control section. Like when you are doing a profile study or when you are trying to develop a soil profile, see how many horizons are there, you have to go for a profile study and you have to take a soil profile section. Similarly, if you want to characterize the moisture, then you have to take a soil moisture control section, and if you want to do a profile study, you have to take a soil series control section, but that is different. So, this is nothing but a portion of the soil that can tell you that what is the moisture percentage in your soil. And see from the figure, it is very evident. If it is clay, we will only take 10 to 30 centimeter. If it is loamy, 20 to 60, and if it is sandy, then 30 to 90, because in case of sandy soil, the infiltration is very high. So, we have to assume a larger column, and in case of clay, the water holding capacity is high, so we are considering a smaller column. Please do remember the names. Ma'am, please repeat this with capillary water once. Okay, I said that because soil moisture, why do we need to find out the soil moisture? Because it is directly linked with the plant growth, right? And the capillary water is the only water that is available to the plant growth. So, that is why we take the moisture regime to be in between the field capacity, that is 33 kilopascal, to the permanent wilting point, that is 1500 kilopascal. Clear? Clear? Okay. So, these are all the soil moisture control section, the limitations that you have to maintain, that what should be the moist period, what should be the humic period, okay. And these are the thumb rule. That means, as a thumb rule, any month that has an average precipitation of more than 50 millimeter, it is considered to be partially moist. So, it will keep this moisture control section partially moist if your precipitation is greater than 50 millimeter. Now, if you ask me, ma'am, from where did you get those values? I did not devise the system of classification. These are the protocols that you have to maintain while you are classifying your soil or giving the taxonomy. So, these are the dominant soil moisture regime. So, from saturated only you can know that it is saturated with water, right? So, it is characterized as aqueic. Then non-leaching. Non-leaching means no leaching of the salts will take place, and leaching will only take place if your precipitation is there. So, in case of arid and semi-arid climate, as there is no precipitation, there will not be any leaching. So, it is characterized as acidic. Then leaching is there. So, in case of leaching again, we can have different moisture classification. One is udic. Udic is where it will move, where there will be continuous flow of water. Then we can have oustic and xeric, but that is in between leaching and non-leaching environment. So, can anybody comment that what is the dominant moisture regime in India? Dominant moisture regime in India, what is it? Please comment. Okay. Already it is written that your oustic moisture regime is the most dominant, that is 72% is oustic. Then we have acidic and then we have odic. So, this line is also very important. For oustic, what happens there? We have summer rains, Okay, summer monsoon rains. And for the xeric month, it is Mediterranean climate, that is cold rainy winters. Cold rainy winters are a feature of Mediterranean climate. So these are just the soil moisture regimes that you have to learn or understand. Clear? Now coming to the soil temperature regimes, similar to the moisture regimes, we have to also include that what is our soil temperature, and we actually measure it with the help of mean annual soil temperature. So that mean annual temperature, mean soil temperature is nothing but the relationship between mean annual summer temperature and mean annual winter temperature. Okay, summer season you will check, winter season you will check, you will together do the mean and that will give you the mean soil temperature. So these are all the different temperature regimes. I am not going into details, but one thing you have to remember that whenever we say ISO, the prefix is ISO, that means the mean annual soil temperature difference will not be more than 5. If it is 5 degrees centigrade, more than 5 degrees centigrade, then we will not use the prefix ISO, but if it is less than 5 degrees centigrade, then only we will use the prefix ISO. And in India, thermic and hyperthermic regimes are most dominant. Thermic and hyperthermic. Okay, one thing again I would like to mention, students often get confused between this craic and frigid. See, in case of craic, whenever the question comes, these 0 degree centigrade will be mentioned in the option, 0 to 8. But in case of frigid, we do not have a minimum limit. See, there is no minimum limit. Okay, ma'am, मास्ट है ना तो इंडिया के ही रीजन टू रीजन यस करेगा, तो इसलिए तो हम लोग मीन एनुअल सॉइल टेम्परेचर लेते हैं. We are classifying the soil on a larger basis. You should not specify a particular region. देखो, climate does not change, right? Climate is a condition which is prevailing for more than 30 years. So soil temperature is not subjected to that much fluctuations. In a particular climate, the soil temperature is supposed to vary within a limited or a narrow range only. इसलिए तो like because it differs from region to region, the soil nomenclature also differs from region to region, right? Okay. So this is the final thing. After all the classification, we have 8 soils, 8 different categories of soil in India. The first one starting with alluvial soil. And the first soil map was developed by Madam Shokolaska in 1932. Alluvial soil, you all know that it is generally present in the banks of the rivers, that is alluvium. Old alluvial is bhangar, then new alluvial is khadar. Dominant clay minerals you have to remember, and what are the nutrients, what are the limiting nutrients also you have to remember. So that is, I want the answer in the chat box. What are the limiting nutrients for alluvial soil? Then for the black soil, botty soils, cracking clay soils, black in color, basic it will be, good for cotton cultivation, all that you know. Okay. Then dominant clay mineral is montmorillonite. Red soil, for that it is highly weathered in case of tropical conditions. So kaolinite is the dominant mineral and the order is alphisol. Laterite soil, this laterite term was coined by Buchanan and these are formed by the process of laterization. So I already explained what is laterization. Salt affected soil, you will read it in details in the problematic soil class, so don't worry. Desert soils are those that will belong to arid soils. Arid climate is there. Okay, physical weathering is happening. Forest and hill soil. So in case of forest and hill, that will be present in high rainfall regions. Molly soils very important soil order. Incepti soils, anti soils. So what is your homework? Your homework is you learn that in each and every soil of India, okay, what are the dominant soil orders in each and every category? Dominant soil orders, please to remember. Dominant soil orders. Okay, that you have to remember. Then peaty and marshy soils containing high concentration of peat, that is organic matter, and formed in low-lying areas. So if your peaty and marshy soils might be there if the acidity is too low, okay, comprising of iron pyrites, then we can say that it is acid sulfate. So the details of all the problematic soils, it will be covered. Don't worry, but you have to remember that geographical area, dominant soil orders, what are the Minerals, what are the nutrient deficiencies that are associated with each and every soil? Hmm? Dominant soil is to very, very important. And what are the dominant clay minerals present? So, again coming to promotion time. If you want to cover soil pedology in details with each and every concept, each and every term explained to you in details, you should subscribe to our master course. I am not saying you could, I am saying you should subscribe to our master course, and it is available at a very, very special offer. So, you can easily join that, or even if you want the PDFs, then you can access to our test series or mock test bundles. They also provide quality questions. So this was the end of the soil pedology marathon class. I would love to know how it was for your guys despite the 2 power cuts, but I would love to know that. And if you have any doubts or questions, you can post it. We will be continuing our marathon sessions like this for the upcoming weeks. So please be with us. And today I can see that only the concurrent viewers are 18. But the next day when I take the physics sessions, I want you all to invite all the other guys who are actually preparing for JRF. And I wanted to make this session more interactive. You guys were pretty interactive and it was great fun. Okay. Thank you. Thank you so much.